Unit 6, lesson 4. Okay, so 101 in lesson 2, we learned how to determine the measure of angle given its trig ratio for an angle. For review, complete the following examples. So, how do we get this to know what degree is at 0.45? We did that on Thursday or Friday. Yeah. Yep. Inverse sine. Remember? Inverse sine to both sides. That gets you the x degrees. So like this. Remember that guy to both sides, and then you put the 0.45 in, and it kicks out the degree measure that happens.
24.
Yep.
I got 24. 26.7.
You got 10, yeah. 26.7. Okay. Nearest degrees, so we're going to go 27 degrees. Around the nearest degree, it says. Is it 26.7? Did you do tan or sine? Okay, sine. Okay, so do the same thing with the other one. So it's going to be cos inverse of 0.1624. What's that one? 81. Okay. Tan inverse of 5.2. 79.1. So 79. Okay. So again, just guys listen to me, when you're trying to find a degree measure, you're going to be using sine or cosine inverse. Okay? You're going to see, we're getting to the point, okay, we're getting to the point where you only need a couple things, you're going to be able to solve the rest. Maybe Pythagorean theorem, maybe trig ratios from the last lesson, or maybe we're using this to figure out the degree measure. Because again, once you have 2 degree measures, you really have them all. Okay, so you're going to get to a point where you can, like I can give you probably 2 pieces of information on a triangle, and you can fill the rest out. Okay, that's what we're getting to the point of knowing how to do that. All right, so here, the second one. In order to use the trigonometry ratio to determine the measure of an angle in a right triangle, we need to know the lengths to the sides of the triangle. Complete the following work for the diagram shown relative to angle A. Okay, adjacent side and 34 is the hypotenuse. So the trig ratio, which involves adjacent and hypotenuse, is what? Adjacent hypotenuse is cosine, correct? So cos A is 16 over 34. See how we're setting it up differently? We're trying to find the angle measure. So just like last class, but instead of having a missing on the right side, the missing's on the left side. Like we have these. We don't have this. So now we have to do cosine inverse of 16 over 34. That'll tell me what this degree measure is. Okay, do we get that? 62? Yeah, you good, Aiden? Yeah, in most of, nearest degree. We don't want decimal degrees, so just round the nearest whole degree. Okay. Any question on that? We went through that 2 things quickly. Okay, so again, here's what happened. If you think about last lesson we were like missing this spot, but we had the degree. But now we don't have the degree and we have that spot, so we just continue like we would. We have adjacent hypotenuse. We're missing the angle. Well, that's ca. Yeah, ca. Cos, we don't know, equals 16 over 34 by the ratio. The ratio of missing piece just happens to be degree now. That's when we have to use inverse. You can see at the bottom now they're giving you a bunch of sides but no angles. Okay? So, the thing I want you guys to understand, and the ratios make sense. I like trigonometry because it also does make sense to me. But the thing I want you to realize is that what's the definition of a ratio? Let's just see if we know that first. What's the definition of a ratio? Not necessarily. What's that? Yeah, comparison. So like again, I know when it comes to odds and stuff, a lot of times we gravitate towards gambling type things. If you have 8-to-1 odds, are those good odds? Yeah, that means if you bet $3, you're going to win 24. Okay, if you have 1 to 8 odds, that's not good. Okay, correct. So I mean, it's a bigger risk and reward, right? So what I'm telling you is that every triangle ratio of the sides will determine the angle measure. It has to. Because if I have like 2 here, but my hypotenuse is 36, well, that's going to make my angles form in a way that the ratio will make that possible. That ratio will stay consistent. So we can have an equilateral triangle, for example, just a simple one, all 60s. Is every equilateral triangle the same size? No, I can expand and contract, but no matter what, they'll be all 8, 8, 8, or 25, 25, 25. Those can all change. So what I'm trying to get you to understand is that as these numbers change, the ratios that they create is what is telling you what that is. Okay, that's the cool thing about trigonometry. There's enough information to figure out what the missing piece is. Okay, so if we do this, here we are. Yep, we're opposite over hypotenuse, so we're sine A equals 4 over 6. So all you're doing, inverse sine of 4 over 6. What is it? 42. Okay. So Hannah, what would you use for B? So here's the angle. So what side is 10 and what side is 19 to this angle? Good, 19 is hypotenuse. So we know we're using cosine or sine. You have, is 10 adjacent or opposite? So we're using cos, right? Cos B equals 10 over 19. Inverse cos of 10 over 19 equals B. Somebody have that for me? 58. Okay, let's check out C. So C is funny because, honestly, I can use anything, right? I have all 3 sides. What do you want to use, Trig? Whatever one you want. Tan. So we'll have tan, opposite, adjacent, so TOA, tangent of 21. Oh, no, that's on the video. Shoot. Sorry. I tried to save it, but it didn't happen. It's just going to be on the video. It's all right. People will laugh at me later. Okay. Yeah, this will go viral. Stupid math teacher sneezes. Okay. Tan C is 21 over 20 for tangent. And so we are going to inverse tan. And what do we get? 46, okay. Just for the sake of practice, let's go ahead and verify that sine and cosine are the same, okay? Sure. What's that? Did we not get 46? Oh, okay. Well, let's make sure. So I'm now going to do cosine. If I'm going to do cosine, it's going to be 20 over 29. I don't have to set this up. I know it's going to be inverse. What's cosine inverse of 20 over 29? 46? Did you get it already? Okay, and then sine is opposite over hypotenuse, so sine inverse of 21 over 29. You should get 46. Point is, all those ratios should be equivalent. Okay. All right, I think we got just a little bit more here. All right, so angle of elevation depression. This is a very, very confusing topic because a lot of people think that depression means the looking down, and it's not quite that. Okay, so let me show you what I'm talking about. I would probably start this because these will be on your test, and we will have I think we have a project on this kind of stuff, so I will show you. Yeah, there's a little thing, a little ramp project we'll probably do when we get back, possibly. The angle of elevation is measured upwards from the horizontal. The sketch at the right illustrates the angle of elevation of the helicopter from the boat. So this right here is the angle of elevation. That's not too bad. So the boat's here. The angle of elevation is looking up at the helicopter. Okay, that makes sense. Okay, but now this one's a little bit more confusing. The angle of depression is the measure downwards from the horizontal sketch. So what I'm showing is confusing is, you may say, oh yeah, that makes sense, but a lot of people tend to think this right here is the angle of depression. Okay, they think that is, but it's not. Your angle of depression is your sight line, that's this, and then what you look down. This angle is your angle of depression. Okay, so when you're doing angle depression, just kind of put your arm out, and then it's whatever's between your arm and where you're depressing. Okay, where you're going down from. Okay, so it is not, okay, it's not from my chest here, it's, okay, so it's not this spot here. A lot of people think that's the depression spot. Oops, yeah, okay. So a lot of people, the angle of depression, I'll say it one more time, is your straight ahead sight line and what you look down towards. A lot of people tend to think it's this spot, and it's not. That is not your angle of depression. These two spots are. Okay, because like what I'm telling you this for is you're going to have to draw these. They give you a word problem, you're going to have to draw an angle of depression. So if you're saying, oh, I can see that just fine, but you have to draw this like it wasn't there. Okay. All right, so it says no angles of elevation, angle of depression are determined from the horizontal, not from the vertical. That's what I'm talking about here. It's not determined from here, it's determined from there. Depressing from the horizontal. Okay. All right, that's all we need to talk about there. Now, here we go. Let's see how much you learned. Nothing. Perfect. A tree 5.1 meter tall casts a shadow 7.5 meters long. Calculate the angle of elevation to the sun to the nearest degree. Right there. The sun's coming down. The sun coming down, guys, hits the tree here that creates the shadow. So we're trying to figure out that spot there.
Why don't you figure out the spot at the top of the tree?
It wants elevation, right?
So you say the tree,
Yeah, so the tree's 5.1. The shadow is 7.5. And so now we can figure out the angle of elevation. So we're trying to figure out this angle.
Oh, I get it.
Nope, it's not sine. Tangent. Opposite over adjacent. So tangent. There you go. So it'd be x equals tan inverse. What do we say? 34. Any questions with that setup? It just kind of gets the rhythm.
My project, do you know the course project?
It's not that long. Okay. Questions on this one? Do we understand what it's asking though? No? Okay, what's the confusion? Let's talk about it. It's okay. Thank you, Maddie. That's okay. Okay, so we understand the sun's up here because think about the sun has to be over here or it hits the tree's blocking sunlight, which again creates the shadow. Okay, so that comes down creating this angle that the shadow was created. Like right here, there's no shadow, sunlight's hitting there. Okay, so your shadow distance, your tree distance, which they give us, they want to know the elevation to the sun. Okay, so, and they said from where? Calculate the angle of elevation of the sun to the nearest degree. So elevation of the sun is from that spot there. It's this angle and this angle is the same. So if you're saying is it from the tree or from the ground, it's actually the same. Because the sun's coming down, that angle and that angle are the same. So if you have like this line here, if I cut here and I cut here, these two angles are the same. It doesn't matter. Okay, because the tree's straight up, your ground's straight up. Okay, so I'm just getting the point across that the angle up to the sun from the point of the ground the shadow ends is the same as the angle from the tree, which doesn't matter what they're asking. They weren't very specific. They just want to know the angle of elevation to the sun. Okay, that angle kind of tells you the position of the sun. Okay, long story short. Okay, so Maddie, what else looks confusing? Are you sure? Okay, all right, we got last page here. The boat is 130 meters from the base of the cliff. The cliff is 80 meters high. Draw a diagram representing the scenario that marks the angle of depression of the boat from the top of the cliff. Try this, and I'm going to draw it. I'm going to say 50% of you are probably going to draw the wrong line. Try it, though. Two ways you can draw this. So first off, let's just draw the cliff. Okay, so we got a cliff here. Okay, got a cliff. Okay, there's the wall. Here's our water. Okay, then we got our boat. Okay. Looks like a little Noah's Ark, isn't it? Okay. Oh, no offense, no. Okay. So now it says draw a diagram representing the scenario to mark the angle depression. So remember, I said depression is the view down. You have to do it horizontally. Okay. So the thing we want to understand is, so like from here, the depression goes down to the boat here. That's the angle of depression because the boat's below it. Okay, but now listen, those of you that have this right here as your depression angle, that's still right. These are both the depression angle. These angles are equivalent. Okay? So you can draw it two ways. Here's your two ways. Stay with me. Okay? You can draw it this way. Okay? This right here is the 130. This is 80. Or you can draw it this way. 130, 80. See how they're the same triangle, just flip? These corners match, so this is still the same corner. They have the same lengths. They have the same length. So there's two ways you can draw it. Don't let that confuse you. Okay, I prefer this one because to me this actually looks like depression. This actually looks like it's going down. When you do it from here, it looks like it's going up. That looks like elevation to me. Okay, but again, you can do it either way, just making sure that you have the correct position of your horizontal line. So turn nearest degree, the angle of depression. So we want to figure out this angle. Again, I can use either one, opposite over adjacent. So it's going to be tan D equals 80. Whoops. Look, opposite over adjacent. So I'm using. Yep, it's the same thing. Opposite, that's the point. Adjacent. Yes. You're looking off the cliff, giving yourself a horizontal line.
32.
Okay, 32. So the angle of depression is 32 degrees. For fun. I'm having a fun time. Okay, last one. Last one. Sorry, I'll give you my notes afterwards if I went too fast from here. Okay, consider isosceles triangle KLM in which KL equals 20, LM equals 20. Therefore, it's an isosceles triangle. And KM is 30. So if this is 20, this is 20, this is 30. What do you know about these angles here? They're the same, right? Why? Okay, pause. It's because, guys, this angle makes 20, this angle makes 20, therefore the angles have to be equivalent. Same angles make same sides. Okay? So keep that in mind. Don't just assume that. Some of you guys just... What's that? Yeah, so this one, that means this angle is bigger than these two. Not necessarily. Okay? Why can we not use Sohcahtoa in this triangle? Attaboy, we don't have a right triangle. Okay? So we are not given a right triangle, so we can't use Sohcahtoa. So how can we determine the angles of KLM without using Sohcahtoa? No. Pythagoras right triangle too, right? Oh, yeah. Draw the line here, make your 90.
Wow.
Draw your line, make your 90. So that means this is 15. Okay, good job. Okay, that means that's 15. She's exactly right. Okay. Okay, so we're going to find out what, so we said y, it's not 90. Determine to the nearest degree the measure of KLM by splitting KLM into two congruent triangles, which we did. So we're figuring out KLM. So we're figuring out this angle here. That's my x. So what relationships do I have here? What ratio is that going to be? Opposite hypotenuse, so I'm doing sine x degrees equals 15 over 20. And then sine inverse now. 49. So 49 degrees is KLM. So 49 degrees is KLM. Oh, excuse me. 49 degrees is not KLM. 49 is this guy. So then what's KLM then? Times 2, it's 98. 98 degrees is what angle KLM is. Okay, so the whole thing is 98. So it's bigger than 90.
Why does it say like KLM? Why doesn't it just say the angle of L?
Yeah, L's another way you can do it. Yeah, that's fine.
How do you know you're not trying to find L when it says KLM?
KLM because it's the order. So when you're doing the order, Aiden, it goes KLM. What angle did that make? It made that angle. That's how you read it. Okay, that's a good question. You guys hear what he said? He said, how do I know KLM? What's talking about which angle? Why isn't it called just angle L? It can be called angle L. That's correct. But the 3 points that make an angle, you have to have 3 points that make an angle, right? You have to have, A to B to C. That makes ABC, right? 3 points. KLM, that creates that angle there. Okay, so that's how you read it. So essentially, he's right. The middle letter is where you'll find the angle. So ABC, you'll find it at B. Yeah.
Will you ever make us find the other angle?
Like this guy?
Yeah.
Sure. I mean, yeah, you could, but we don't have too much work for that, right? If that's 49 and that's 90, we just add those and subtract from 180.
Yeah.
So that would just be, I think, 31. Okay. So the ends. So these would be 31, 31. 31 plus 31 is 62. Is it 41? I think it's 41. So 41, 41, that's 82. 82 plus 98 is 180. So the whole thing's 180 again. Okay, all right, we're done with that. Okay, you still have 20 minutes. A lot of you already burned through that worksheet. Good job.